Welcome to session 35. We cover volume, surface area, and coordinate geometry. The good news, every volume and surface area formula is printed on the SAT reference sheet, so the skill is using them quickly and reading the question carefully. You will use the volume formulas quickly, find distance and midpoint on the coordinate plane, and scale lengths, areas, and volumes by k, k squared, and k cubed. Let's start with volume. Picture a cylinder with radius r and height h. Volume is always about filling a solid with cubes. A box is length times width times height. A cylinder is pi r squared times the height, the base circle times how tall it is. A cone is 1/3 of that cylinder. A sphere is 4/3 pi r cubed. And a pyramid is 1/3 of the base area times the height. So, a cylinder with radius 3 and height 10 has volume pi times 9 times 10, which is 90 pi. Just be careful, cones and pyramids always carry that 1/3. Surface area is the total area of the outside, so it adds up flat faces. Picture a box with length, width, and height. A box has 3 pairs of matching faces, so its surface area is 2 times length width, plus length height, plus width height. A cube is the simple case, 6 identical squares, 6s squared. A cylinder is 2 circles plus the wraparound, 2 pi r squared plus 2 pi r h. For a 3 by 4 by 5 box, that's 2 times the sum 12, 15, 20, which is 94. For a cylinder with radius 4 and height 6, it's 32 pi plus 48 pi, which is 80 pi. On the coordinate plane, 2 formulas do the heavy lifting. Take 2 points, A and B. The distance between them is the square root of the change in x squared plus the change in y squared, which is just the Pythagorean theorem. The midpoint is the average of the x's and the average of the y's. For A, -3, 4, and B, 5, -2, the distance is the square root of 64 plus 36, which is 10. And the midpoint of 1, 2, and 7, 10 is 4, 6. 2 traps to avoid. In distance, you square the sum, and in midpoint, you must divide by 2. When 2 figures are similar, one linear scale factor k controls everything. Here, the bigger square is twice the smaller, so k is 2. Lengths scale by k, but areas scale by k squared, because area has 2 dimensions, and volumes scale by k cubed, 3 dimensions. So 2 cylinders with radii 2 to 1 have volumes 8 to 1. If the small one is 20 pi, the big one is 160 pi. And working backward, if volumes are 1 to 27, the scale factor is 3, so surface areas are 1 to 9. Sometimes, the SAT builds a shape from 2 solids. A classic is a silo, a cylinder with a dome, a hemisphere, on top. Here the radius is 5, and the cylinder height is 10. Find each piece, then add. The cylinder is pi times 25 times 10, which is 250 pi. The dome is half of a full sphere. Half of 4/3 pi times 125 is 250 pi over 3. Add them together. 250 pi plus 250 pi over 3 is 1000 pi over 3. The trick is simply to handle each solid separately and then combine. Your turn. Find the volume of a cone with radius 6 and height 9. Pause the video and don't forget what makes a cone special. A cone is 1/3 pi r squared h. Plug in 1/3 times pi times 36 times 9. 36 times 9 is 324, and 1/3 of that is 108. So the volume is 108 pi. The 1/3 is the whole game here. Let's recap session 35. For volume, remember a prism is LWH, a cylinder is pi r squared h, and a sphere is 4/3 pi r cubed, while cones and pyramids carry a 1/3. Surface area adds up the faces in squared units. On the coordinate plane, distance is the Pythagorean theorem, and the midpoint is the average of the coordinates. And for similar figures, length scale by k, areas by k squared, and volumes by k cubed.